Okay. All right, so first thing that we're going to talk about is the expectation for project, because you're going to have to present the project next week, and then at the same time, after you're done, you're going to turn in the assessment of partner help. There's a paper that you're supposed to download. And so this particular week's project is not extremely long. If you'll notice, all of those are pretty straightforward, but you're going to have to explain to the class what geometry skills are involved in solving that problem, because the other students will not have looked at the problem that you did. Does that make sense? Okay, so you're going to get up and give a presentation. You have to not trip over these wires and stuff like that. You'll probably have to write something on the board as well to help try to explain what's going on. Either that, or what you might do, because we have such a small group, that if you brought an extra paper for, 3 extra papers, then you could put one there, and give one to me, and everybody could look at what you're presenting off your paper. Does that make sense? And again, it's up to you how you do that, but in the presentation style, that may work, especially with how straightforward some of these projects were in this group. Okay, so that takes us to where we are at right now. So next week, you're going to do that. We're going to complete the Chapter 2 review test, and we'll do that in just a minute together, and you'll take some notes. And then there's going to be a quiz, and depending on the day, we may do that in class, or we may give that as a homework assignment and you upload it. And then we're also going to go and look at part of Chapter 3 as well. Okay.
Didn't we do quiz 2 last week?
That may be what's there. I think I may have gotten ahead.
That's what I thought. Yeah,
yes. Okay. Yeah. All right. That's good. Then I've got that to give back to you too, which I'll do later. All right. So having done that, what we're going to do is we're going to look at the review. Whoa. Did I change that? Yeah, okay. Let's see. I've got to try to figure out how to move this. Okay, so turn in your books to page 59. You don't have your books?
It's only on the drive.
All right, well, here it is. Okay. All right, so, get out a piece of scratch paper then. I've got a book, that's where I was thinking of that. All right, okay, so this is your scratch paper. So I'd like you to do problem number 1 only. All right, we'll talk about it. So do problem number 1 only. It has 4 parts to it.
It's really 4. It drives me crazy.
Okay.
It's like it's 4 problems.
All right. All right, if you're stumped on what to do, draw a picture. Now, the first one you should be a slam dunk, right? Okay. So now go to the next one, draw a picture. All right, how many triangles can you make out of that? And how many's in each triangle? what you're supposed to know is that the number of degrees inside the polygon is 180 degrees, which is the degrees of a triangle, times however many sides minus 2. All right, that was one of the things that we did last week. And so for a triangle, because a triangle has 3 sides, this is 180. If I had a quadrilateral that wasn't even perfect, and I can draw from here, I have 1, 2, 3 vertices. The 2 on the outside are part of the outside of the figure, and so I end up drawing this one here, and I end up with 2 triangles, right? Which is 4 minus 2 is 2 triangles. If I have a 5-sided figure, and I start here, I have the 2 on the outside, and I draw those 2 lines, but I have 1, 2, 3 triangles, which is 5 minus 2. And so I have 3 times 180, and that one you'd have to put in the calculator because my brain's fried right now. All right, so what would you do with a hexagon if you didn't know what a hexagon was? All right, how many sides does a hexagon have? 6. So what are you going to multiply?
4.
4 times 180. Now, if they were all regular polygons, like for instance, what is the 4 times 180? Hexagon, how many sides?
720.
720. Okay, there's 720 degrees total. All right, how many angles are there in a hexagon? How many angles in a hexagon? 6. Therefore, if I want to know in a regular hexagon how many is in each, I take this number divided by 6. So I take 180 and multiply it by n minus 2, but then I divide it by n to get in a regular polygon what the value of each. Okay. Now the reason I said that is, let's say that we have a 15-agon. Okay. What's the math for the total number? No, don't put it in yet. What's the math for the total number of degrees inside that polygon?
180.
180 times 13. If it were a regular, what would I have to do to find the value in each? I would have to divide it by 15. And that's what I want you to see, is I want you to see what the math is to be able to get any particular regular polygon. Okay. So you're going to take the number of triangles, because of those 2 outside parts, is going to be n minus 2. But then for the regular polygon, you have to go back to the 15. Because what happens a lot of times is people want to divide it by 13 because they forget that the 2 functions are different. Okay? All right, so when you have your chapter test, do you think that's going to be on the test? Oh yeah, without a doubt. Okay? Now, all right, this is what I just showed you. So, if n is 3, all right, I'm going to take 180, n minus 2, and then divide it by n. Okay, now, you want to know something that's really tricky? You got your calculator? Put that in y equals. No calculator, Tony? Now come on.
It's in a box and stuff.
You haven't got it out yet?
We don't move till October.
You may have to go look for it.
It's in the back. Under a bunch of tables and stuff.
Then, I don't know, can you get, well, this Kara's got one, can you borrow
Yeah, we're
one?
gonna ask Karen tomorrow.
So if you put this in y equals, and then you go to the table, what does n have to be for this answer? Go to the table, find out what 3 is.
It's 180.
Should be 60.
Oh, well, I was saying,
Yeah, 60.
it's 3 times, it's 1 times 180, which is before you divide it.
Yeah, but did you put that in to y equals?
I did.
Okay, and, so you should have 180, parentheses, n minus 2, close parentheses, divided by n. Or only you've got x instead of n, right? Okay, so 3 should give you a y of 60, does it?
Well, it's not zoomed out.
What?
It's not zoomed out.
No, do a second equal. And then it should be there.
Look at, you see in the table? Now, get to an x of 3.
It all should be 60.
You find them in it or not? Let me see what you got here. All right, first of all, y equals, that's supposed to be an x, and you got it divided by 2, that's supposed to be an x.
Yes.
So put an x there and an x there. Yeah. What you should have in the calculator is 180 parentheses x minus 2 divided by x. All right, simple, right? You feel foolish. Okay. Now, see, also, what we're doing here is preparation for the college algebra class, because in a college algebra class, you're going to let the calculator do the work, and you're going to extract the information off the calculator. All right, Bennett, do you see it now? Now, what happens when x is 3 in that list? Move your arrows up and down till you see an x of 3 and read the y.
60.
60. Okay, now watch how easy this is. Then what happens when x is 4? 90, right? When x is 5? 108. When x is 6?
120.
And 107. Now, see how simple that is? All right? That's allowing, but what happens if you don't know this formula? If you don't know that formula, then you've got to do it the long way. Okay, now, if you were asked for the number of degrees in a triangle, how in the world did I get to there? You see it? Man, it's not working right. What happened? That's the old one. Here's chapter 2. Where'd it go? Come off of it. All right, that's good.
What would be the most without splitting a degree everything to a decimal? What is the most side do you get? See, so if each angle is 79
the
degrees,
most sides?
179. So I'm thinking every angle is 179 degrees.
Yes.
How? Because that without splitting
Yeah.
into 79 point whatever.
Okay.
How many angles would that be?
All right. Okay. We could look at that mathematically. Let me get to the right page here. Number 49. Where'd it go? Here we go. Self-test. It's weird. What is going on? I lost the page. Oh my. Let's go back again. Geometry lessons, page 79. All right, so I go to here. 43. No. It's not there.
But never with
What
smart
in the world? Oh, man. Page 59. How do I get on the right one? Okay, let's try it again. All right. This is not working. What is going on here? This is crazy. I'm sorry.
That makes sense. 360 angles.
All right. Here we go. All right, here we are. Okay, so, all right, let's answer Bennett's question. All right, okay, so if we're trying to find the angles here, we're going to go 180 times n minus 2 divided by n. And it has to equal, let's say it equals 179 degrees. Okay? All right, so the first thing I've got to do is get rid of this n. So I'm going to multiply. So I'll have 180n minus 360, if I distribute here, equals 179n. Okay? Subtract 179, that's 180, sorry. Subtract 179, that gives me n equals 360. So it would be a 360 degree, or 360 side polygon, and it's going to look almost like a huge circle. Because it's barely going to change. And so it may take a couple of miles for you to actually see the change. All right? But that's mathematically what would happen. Okay, now, so what happens in this part with your calculations that's different from this part? For the calculations, what is the mathematics that you need to calculate this part? 180 times what? N minus 2. In this one, you have to also divide by n. So it's 180, n minus 2 divided by n is what you get for the angle of each. Okay, all right, now let's look at the next part. That should be slam dunk. Okay? So, use your calculator, find x. Well, it has to be a 9 because that's a 1. So it has to be a 9.
Yeah.
Right? And so that makes 60 and then 30 to make 90.
Wait.
So it's 39. Because this is 90, right? 180 minus 90 minus 51.
180 minus 90 minus 51. 30.
39.
Huh.
See, I knew that these two had to add up to 90 because 90 plus 90 is 180. And so what I did was say, okay, if I'm at 151, what do I add to get to 69? And from 60 to 90 is another 30. Okay, now, in this one, we have 1, 2, 3, 4. So what's our total angles measurement? Total angle measurement?
360.
360. All right, and what does it equal? It equals 1, 3, 4, 5, 9. I'm not finishing it, but that's it.
40.
Kinda,
Yeah.
yeah.
You have to isolate the variable.
Yes, and so you're going to divide both sides by 9.
Yeah.
Okay, all right, now, this one is involved with those vocabulary words for parallel lines are concerned. Because these two are both 90 degrees, these lines are parallel. They're not going to, so therefore I have parallel lines and they're cut by a transversal. So this is 58 degrees, and I'm going to do this. 1, 2, 3, 4, 5, 6, and X. Which other angles are also 58 degrees?
1, 4.
6.
Okay, all right, okay. One is why, and what's the vocabulary word for 1 versus the 58? Vertical angles, very good, okay. And then somebody said 6. Okay, 6 is correct. All right, but what's the vocabulary word?
Corresponding.
Corresponding. Because they're both, this is in the lower right, this is lower right. Okay, then what about 4?
Vertical.
No? Versus 58.
Interior run.
Alternating interior angle. Okay, so all of those are 58, all the others are supplementary. So that means X has to have a 2 in it to get to 60, and then another 120 to get to 180. So that makes the X value 122, 5 is 122, 3 is 122. Okay, so X and 3 are what vocabulary word? X and 3. Yes, corresponding. Okay, X and 2 are what vocabulary word?
Alternating exterior.
Alternating exterior, good. Okay? All right, now, this one has a triangle on the inside. So we need the value of 1 and the value of 2. Or we can see that this is exterior, right? And this exterior angle is equal to 1 plus 3. Right? Because 1 plus 2 plus 3 is 180, and X plus 2 is 180. That means X has to be the same as 1 plus 2. Okay? Well, 2 is 20 degrees. What's angle number 1?
70 or 50.
50, when you add the two of them together, 50 plus 20 is X equals 70.
Wait, wouldn't 2 equal the other, which is yx equals 7? That makes sense.
Okay, yeah, that's called the exterior angle theorem. Is that the exterior angle is the same as the sum of the two remote angles. Because this plus 2 is 180, and X plus 2 is 180. That means X has to be the same as both of these added together. X plus 2 equals 180. 180 also equals 1 plus 2 plus 3. If I take the 2 out, X has to be 1 plus 3. That's called the remote angle theorem. Okay. Now, number 4 says, what are the angles of a certain parallelogram? What's that mean? Parallelogram. Parallelogram, both sides are parallel. They don't have to be a rectangle, but both sides are parallel. Okay, is twice the size of the other angle. Okay, so we have a parallelogram. This is x, and this is 2x, and this is x, and this is 2x. So how do you find the angles? Okay, you've got 2 ways to do it.
60.
How do you find it? And that's what it was. How do you find it?
How do you find it?
All right, now, how is this and this similar?
Because they're both four-sided.
Okay. So what are you going to do to find? You're add them together and get what total?
360.
Why 360, Casey? Why 360?
I don't know.
Because that's 2 triangles,
Oh.
right?
Yes.
So it's 4 minus 2 is 2 triangles, so 2 times 180 is 360. So you have 360 equals how many x's?
4.
Keep looking better at that. Huh?
6.
6x. So 6x equals 360.
Oh,
It's getting really crazy in here. See, look at this one right here. Okay, we already know this because this was the start of chapter number 2, where we were talking about where this was the river and we're coming down and we're reflecting across so that these 2 angles were the same, right? Well, that's this thing right here. Okay, now, if you have a right angle here, then in this triangle, all right, you know that these 2 angles you could calculate, then how do you find this value here? Where the cursor is. How do you find that? We just did that in that previous problem, right? In that self-check problem, all right, where we had a right angle in 1 degree, you had to find the other degree. All right, well, what they did is they give you this angle and you have to find this one. But if this is a reflection, then what do you know about the outside angles here in the top and the bottom of this intersection? They're the same. And so you could, because the 3 of them add up to 180, you could find this angle of reflection. And what it shows is that if these 2 are parallel, then the corresponding angle that's inside here is the same as this angle over here because they're both corresponding angles. Right? This angle on the inside plus this angle here equals 180 because they are same side interior angles. Right? And so this particular project or problem, you begin to see how those things relate. Okay? And again, we're going through geometry pretty quickly, so we're not going to get to that part. Okay, so you'll have a chapter test. That'll be that part of it here. Okay, now we're going to this. Okay, now, Do you have a straight edge with a ruler measurements? Does anybody not have one?
What's this straight?
Straight edge, a ruler, a straight edge with ruler. Okay, all right. Do not.
I have a protractor.
Well, a protractor, yeah, is it graduated on the bottom or is it?
What does that mean?
That means it's got marks like a ruler on the bottom of it.
Yes.
Oh, yes, I have it.
See, I thought I had one in hand. There we go. Yeah, here we go.
I don't know why, but it seems to be like metal.
Okay, does yours have a ruler on the bottom?
Yes.
Okay. Right, Casey, you got one, everybody's got one? Okay, all right, now this says for problem A, you have to draw this. It says Lori and Brad are 4 miles apart. Brad sees Lori and also sees an oak tree. The angle formed by drawing a line from Brad to Lori and drawing a line from Brad to the oak tree is 43 degrees. The tree is 3 miles from Lori. How far is the tree from Brad? So what you're going to have to do is you're going to have to make a scale drawing. So this is the start of chapter 3. So we're going to begin to discover stuff. And so let's look at it. So it says, Lori and Brad are 4 miles apart. All right, what does that mean as far as your scale drawing is concerned?
4 inches.
Either 4 inches or 4 centimeters, probably 4 inches on your paper. So, and then you're going to have to make an L and a B for Lori and Brad.
Which side is Lori on?
I don't know that it matters. It doesn't matter. Okay.
Yes.
Why do you need it?
Well, because he's already looking at what he has to do next. Wait, but you're going to need it. Who else has got a protractor?
I have one, but I don't need it.
You will for this, but all right. So you guys borrow, trade that one, and if you would give yours to Bennett, then
I
they've
took one
got.
out of my bag for some reason. I
You
took
took
my
it out?
protractor
Yeah.
out of my bag for some reason.
Okay. It's all right.
You have 2?
Okay. All right. Now. All right. So if I were doing this, I would have a line, a straight line, where the B and the L are 4 units apart. Okay, and then that will allow you to say the angle formed by drawing a line from Brad to Lori and drawing a line from the B to the tree is 43 degrees. So you set your protractor where the indicator point is on B and then mark a 43 degree angle. Now the problem is you can make a 43 degree angle in 2 different directions. So you want the inside angle to be 43 degrees. All right, you've got a line segment, right? Folks,
How do you use a protractor?
you've got a line segment like this, and this is where the B is, this is the L. You can have it in the opposite direction. Then you're going to set your protractor with the indicator line right on the B. And then you're going to find the 43 degrees, and you're going to end up drawing that line. So that this is 43 degrees. All right, now, all right, so this line has to be some sort of length, but now where is the tree located? Now, the tree is 3 miles from Loring. So that means we have to measure
3 inches.
from L to that line, and it has to be 3 inches. All right?
But it
See?
doesn't matter how long that one.
Well, see, this was 4, right? And we have this degrees, and now we're going to have this line right here, and it has to be 3. So you're going to have to move your ruler until you find out where the tree is, so that this line right here is exactly 3 centimeters or 3 inches, whichever you're using. Okay, now, that makes the T right there for the tree. Now you can measure from T to B and find out how far Brad is from the tree. You compare
Brad
it,
is
same?
1.5 inches.
Same? Well, compare with your partner first.
Uh-oh, where is Brad from the tree?
He said 1.5 inches. She said 2.5. I said 2 3/4. So
He's 1.5 inches from the tree.
Yeah, 1 inch.
We have 1.5 inches from the tree.
Okay, so wait a minute. Now, what are you doing? All right, so this was 4, and you got from this point, from L to where it touched this 43-degree line, that had to be 3 inches. So you moved the ruler so it got straight where it's 3 inches.
well, I didn't measure. But this is it's very tiny.
Well,
Here, use this.
You don't like my tiny brother?
That one's better for you.
Nice.
Ah,
Because you can move this around and you can mark it.
turd blossom.
Where did you get that from?
okay.
I know.
I'm on board.
All right, okay, now, so what we're doing here is that we have a side and we have an angle. And we are beginning to look at the triangle. Okay? All right, now all right, everybody, did you guys get your angle correct?
Yeah, that's fine.
Yours is fine, okay. But I think that the measurement, did you get from B to T, you got 1.5?
From B to T,
What'd you get, 1.5?
1.5.
What did you get?
1.5.
Okay. All right, okay, now let's look at the next one, right? So let's take your, you probably have to turn your paper over. All right, and it says that Chris and Allie, I'm going to move this up a bit so you can see it. Chris and Allie are 3 miles apart. Well, that's not hard, right? So now we're going to have a line, and we're going to put Chris here. This is going to be 3, and that's going to be Allie. So now, and then it says, each can see a statue. The angle between the line from Chris to Allie and the line from Chris to the statue is 73 degrees. So that means the statue is up here, and the line from there to here is 73 degrees. All right, now you've got to construct that very accurately.
So,
And then the other one says that between here and here is 51 degrees. And they want to know, where's the statue? And do you notice that the statue is going to be where those 2 lines cross? All right, the question is, how far is the statue from each person? All All right, so that means once you get the two lines drawn, then you're gonna have to measure the two sides.
It's almost 3 inches from the A person.
Casey, can we have that protractor?
Which one?
Either one.
Yeah, either one.
Because you're trying to draw a protractor, you haven't seen the angles yet?
Broke it.
Oh, no.
I don't really care. I'll just get a new one.
That's Abby's though.
Oh, that?
That's mine. That's his.
That's mine.
That should pop in there.
That's mine.
Yeah.
I'll just get a new one.
I mean, you don't really need that.
You don't need it, you don't need it. All the protractors in the world for that one are just round. Okay. All right, so get the measurements. We know the one side and the bottom is 3. You've got to get the measurement of the other sides.
This line is 3.
This is not right.
Yes, it
This
is.
line is 3.
No.
3 inches. So I got for the,
Diagonal line.
yeah.
Yes, 3.
So S to A is 3.
Yes,
S to A is 3.
Mine isn't 3.
All right, and then C to S.
C to S is 1 and 3.
That's like 1.5.
1 3/4.
Mine's 1.5.
Mine's wrong. I don't know.
That's 1.5.
Get it wrong.
Okay, all right, so it's somewhere in that. So if both of the sides, if the first side and the base is both 3, what's the name of that triangle if they were both 3, exactly 3? Starts with an I. That would be an isosceles triangle. Okay. Now, to verify that, the isosceles triangle, the base of that one angle is 73, the base of the top angle should also be 73. So double check that, double check that. Check the angle up at S and see if it is 73 degrees. You might have to extend your lines a bit for it to cross your protractor. Where'd you get that? Huh?
I think it is 70.
It's pretty close. Okay. All right. Then within the, it looks like within the error that we get from the pencil size. Okay. Now the one problem that we've got to get back and look at is this first one again. Okay, because we didn't have a choice on the one we just did because the two lines meet at a particular point. All right, and so that point was gotten for us. All right, now it says that Lori and Brad are 4 miles apart. So again, I'm going to take a line and I'm going to put Lori here and I'm going to put Brad here. Okay, now it says the line from Lori to Brad to the tree is 43 degrees. What happens if this is 43 degrees? Is it possible?
If what is?
Suppose this is where the 43 degrees is instead of this being the 43 degrees. Because we all did that one that's dotted is the 43 degrees, right?
So
What happens if it's that one and then I say from here to here is 3. Now what happens to this measurement all the way back to Lori? Versus this is 3 and I have this measurement back to Lori. You see that from the statue was a statue, wasn't it? Oh no, from the tree to Lori could be two different things. Right? But in the one we did second, there was only one drawing that was possible. Okay? All right. And that is going to lead into what this says. Each of these problems represents an idea about triangles that we're going to examine in chapter 3. All right, we will see why problems B, C, and D, and we just did the B problem, why they have one solution while problem A has two solutions. Okay, and it's going to have to do with what we're going to end up memorizing. We're going to memorize certain relationships between sides and angles. Some of them will produce exactly the same situation. They're called congruent triangles. Whereas this one, I have two different triangles I could form. All right, so based on the information that I gave you, this one does not produce a congruent triangle. It produces two possible triangles, where this information produces one and only one triangle. All right? Because when you do this, and you set these two apart by, what was it, 3 miles? And then you put an angle here, and you put another angle here, they always meet at the same place. And what we're going to find, that this is called angle, side, angle. When you're given angle, side, angle, that point right there will automatically be in the same place each time. And so any triangle that has angle, side, angle, and another triangle with exactly the same measurements, the triangles themselves will be congruent. Because there's only one place where these two lines meet. Whereas in this one, we have more than one possibility, even though we had a side, and an angle, they did not produce one and only one. Okay, so that's what we're going to be looking at in this particular chapter as we move on into it. Yes?
Yeah, I go with that.
You may. All right, that's what the break was for. Okay? All right, so let's look at D in this one while Bennett is going to wherever he's going. All right, and let's look at B. So it says Tanya and Lana are 2 miles apart. All right, and that's not hard. And each can see the other. Both see a ship at sea. The ship is 1.75 miles from Lana and 3 miles from Tanya. Okay, now, the problem with this is that technically you need a compass. Okay, so let's look at, there's a way you can actually do it. All right, if you have, so you have this line here, and you have this line here, and it's 2 miles apart, right? Okay, so this, let's do the 3 miles. Okay, if you come up here 3 miles, and then you draw a circle here 3 miles, you have a circle that goes like this. And because it's 3 miles, it's actually going to end up over here, right? And what you can do is actually just draw a little loop, which is what a compass would do. Okay, so from here, and this is going to be Tanya. All right, you have this. All right, so we know that it's 3, but we don't know where it's going to end up being. Now, the other one here is 1.5. So it's going to be like this, and it's going to be a half circle that touches 1.5 here and 1.5 here, and they're both going to meet right there. So we know the length of this side, we know the length of this side, and we know the length of this 2 side, and there's only one place for that connection where they all meet at the same time. Right? And that's what a compass does in constructions, is be able to do that. Okay? So that becomes another one of those things to where there's only one, given the length of the sides, there's only one place where they will form a triangle. And then we could, from there, we could find the angles just by measuring the angles. Okay? All right, so those are the things that are going on. All right, now, all right, don't want to do that. All right, by taping straws or wood strips to a piece of paper and construction, all right, first of all, does 5, 7, and 9-inch strips, will they form a triangle?
Yes,
All right, why?
because 9 is not greater than 5 and 7 combined.
Very good. Okay, that is the angle side measurement theorem, is that the sum of the shorter tube has to be greater than the longest side. And so when you add 5 and 7 together and get 12, therefore you're going to form a triangle. Now, the size of the triangle on its greatest is the name of it. Right? This is probably going to form an obtuse scalene triangle. Scalene because all 3 sides are different, and obtuse because the largest angle is greater than 90. Okay, so that now, and it says compare your triangle, so you would actually have to put it together. Now, here's a question. If you have 3 sides, will your triangle look exactly like somebody else's triangle that also has those same measurements?
No.
No.
All right, it could be yes and it could be no. All right, you're saying no, why?
I don't really know. I'm just thinking that maybe they could. I don't know.
All right, okay, let's say that you lay one of those sides down here. How many choices do you have?
3.
You got 3 choices. So the orientation of it could change, right? But if you laid one of them down here and you connected a second side to this end and a third side to this end, they would stop and they would flop and form a triangle, right? But the orientation would look, it might have been flipped, it could have been rotated, right? But there's only one triangle that you can make that has a side of 5, a side of 7, and a side of 9. But how you orient that can switch. So the answer is both yes and no, right? That do they look the same? The answer is no. They don't have to look the same, but they will be congruent with each other if you can flip them and rotate them. They'll actually be the same, because what's your shortest side?
5.
And what's my shortest side?
5.
So, you know, and again, and then on one side, you're going to have a 7, right? Well, what happens if your left side is a 7 and my left side is a 9? All you have to do is take that thing and flip it over. You know, lift it up, flip it over, and now the right side will be the same as yours, right? And so the orientation can change, but if you have 3 sides, we'll have the same congruent triangle, it's just displayed differently. All right, and when you talk about right triangles, okay, this is what a teacher will do. All right, that's a right triangle. Are those 2 the same triangles?
Yes.
If the lengths were the same, I could, you know, if I would have made all the lengths the same, those would have been congruent triangles, but boy, they don't look like they're congruent, do they? Because their orientation is different, right? And so that's one of the things you've got to be careful of, is that changing the orientation may present it differently, but you're going to have to determine whether or not the triangles represent one unique triangle, or whether or not they could represent more than one. Okay, so that's what we're looking at. All right, now. Okay, so now let's look at this. Are those two figures congruent?
Yeah.
What are they?
Squares.
They're both squares. But now, a sixth grader would say, no, one of them is a square and the other one's a diamond. Right? Because, no, they would be right from their perspective because they aren't looking at it with the fact that the second one, the diamond, is just a square that's been rotated. Okay? And if we were to rotate it back 45 degrees, then the two squares would be oriented the same, and we'd say everybody would say they're congruent. Right? And so what makes these congruent is that there's a corresponding side to match the other corresponding side, and there's a corresponding angle to match the other corresponding angle, even if you've got to go to a different place to start. Okay, so that's what makes them congruent. All right, now. Okay, so in each of the following problems, a pair of figures is shown together with information. All right, the pictures are often distorted. Decide which pairs are congruent and which are not. Okay? All right, now, if you look at A, these two sides, okay, are they going to be congruent?
Yes.
Yes.
Okay, why?
Because if you flip that one.
Okay, all right, now, all right, look at the length of 4 in the one and the length of 4 in the other.
One's shorter than the other.
Okay, so they're not to scale. They're not to scale, right?
They're not to scale.
Right. But if you start now, remember what we did with the angles in our opening drawing, right? If I have a 70-degree angle that's shooting out in both directions, and I go back and measure on that 70-degree angle, if I measure a 4 on this side and a 3 on this side, those points will be the same on both triangles if they were to scale. Does that make sense now? You see what I'm saying? So if this was written to scale, those triangles are supposed to be congruent. They're supposed to look the same. By the way, in the first triangle, is 4 and 3, are they the same length?
No.
Look at them, but they are in that triangle. The first triangle, the 4 side and the 3 side are the same length. Right? In the second triangle, it looks like the 4 is too long for proportion, right? But based on what we see, we're going to find that those two triangles are congruent because there's only one way to draw them correctly to scale. Okay? All right, now let's look at the second one. A little bit easier. Are those two congruent?
Yes.
Why?
No.
No. Why?
Yes. No. Yeah. No.
Yes or no? Why?
Yes.
Why?
No.
Yes.
Okay, which, first of all, are they congruent?
No.
Why?
Yes.
I don't know.
I don't know.
Well, first of all, okay, let me ask you a
See.
question. What does congruent mean?
Same.
Same size and shape.
Oh, then no.
Why?
Because they're not the same size.
They're not the same shape.
They're the same.
They're not the same
They're not the same size.
Well, wait a minute. One is 4, the length is 4, and the width is 2. What about the other one?
The length is 2 and the width is.
All right, but what happens if you rotate it 90 degrees?
Then the length is 4 and the width is 2.
All right, so it looks like that they are congruent. It's just one was rotated, but based on the lengths, if those are parallel lines, which is an assumption, right? We're assuming that the bottom one is also 4 and not 4.2. Right? But it looks like that they're congruent. Oh, it says they're rectangles. Okay, I'm sorry. It does say rectangles. All right, but one of them has been oriented. Now, just because you turn it and rotate it, does that change its shape? No, it does not. It's still a rectangle with a length of 4 and a height of 2.
Wait, so they are?
They are congruent, yes.
But it looks skinnier.
I know, but look at the numbers.
Oh.
See, remember the first one here? All right, this length is 4 and that's 4. This length is 3 and that length's 3. But these two, they look like it's 3 and 3, and this one it looks like it's 5 and 3. But based on the numbers, that's a congruent situation. The same thing is true here, based on the numbers. Right? And I think I remember telling you this the first week, is that the way that you keep people from looking at it and answering is that you give them things that are not to scale. Right? Not to scale. Right? In fact, if I had this, I might make this triangle, or I'm sorry, this rectangle look like that, with a 2 and a 4. So you can't mistake it to be different sized. All right? But if I put down here, not to scale, then you have to look at the numbers. Right? The width or height of this is 2, the height of that one is 2, the length of this one is 4, the length of this one is 4. They're both rectangles, so they're congruent, but those are really rotten drawings. Right? You get the difference? See, that's the mathematics of geometry, right? Whereas before, in the lower grades, if they were congruent, they would make them the same size and shape so that you could look at it and know it was true just by what you were observing instead of using the math to be able to find out whether it's true. Okay? All right, now, I realize we're running late. Got 4 minutes. So, let's see, where are we at here? Geometry lesson plans. All right, so, all right, see, we've done this. Here's the assignment down here. Let's see if I can make this a little bit bigger. All right, so first part of class next week is going to be presenting your project.
We're presenting it next week.
Presenting it, yes. But that's only going to take about 10 minutes. You're not going to have 40 minutes because most of the fact they're pretty they're straightforward things. But you're going to demonstrate the skills of chapter 1 or chapter 2 to the students who have not seen the project that you're going to be explaining. Okay, and let's agree to do this. Bring 2 extra copies of what you're going to turn into me, so that we can give those to the other students, so that they'll be able to see it, and that because we won't have the projector of it. Okay, that makes sense? Okay, so now the chapter 2 test I'm going to email. All right, and then you're supposed to read and do 79 to 93, introduction to proofs. All right, now, and then you're going to complete this intro. And again, I'll put this all up in here, and then I'm going to send you the prerequisite for the college algebra class. All right, so you're basically going to go through page 93. All right. And again, I'll put this up on the teacher page for you to be able to copy down, and I will send you both the chapter test and the college prerequisite. Okay. Now, also, if we get some extra time next week, I don't know how much extra we're going to have. If you have any questions about the prerequisite work, then let me know and we'll discuss it. Some of them is just being reminded of things you've done in the past. But being able to get through those. If you could imagine you had 1 week to do everything you've done on prerequisite and we're only halfway there. You know, trying to do 79 pages in 1 week was impossible. They couldn't do it. And so that's the reason that we're adding that now in this class. All right, any questions? All right, thank you for a good lesson. I appreciate it, and you're dismissed.